continue our discussion on classical astronomy. And so you noticed that from our from our previous lecture video, we're only talking about the sun, the stars, the moon, and then the earth. And so we are limited to these concepts simply because we're talking about ancient thoughts on the universe. And so this time we go further in time. We now go to the classical period. And so still, of course, we have naked eye observations and then later supplemented by telescopic observations only. Okay? And so one intriguing idea during the classical period is whether the earth is flat or the earth is round. And so, well, obviously nowadays we can say that the earth is round simply because we have proven this from pictures coming from our observatories that the earth is indeed round, unless you belong to the flat earth society wherein you still believe that the earth is flat anyway. And so during that time, since we do not have telescopes yet or any modern equipments for that, it's still a puzzle among astronomers or among ancient people whether the earth is flat or round. Okay? Pythagoras suspected that the earth is indeed round around 500 BC, and Aristotle observed it around 384 to 322 BC. Now, how did they make these observations? First off is by observing at our moon. And so, of course, during their time, they can see that the moon is round. Therefore, they thought that the earth might also be round. And so Aristotle was able to prove that the earth is indeed round by observing the shadow being cast by the earth during eclipses on the surface of the moon. And so earth's shadow appears to be round. Therefore, the earth, Aristotle was able to prove that the earth is round. Okay? Moving on, another idea coming from classical astronomy is on calculating the Earth's circumference. Okay? This is without modern measuring devices. And so we have Eratosthenes, or in some books they use Eratosthenes, 276 to 195 BC. And so he simply used measurement and geometry to be able to come up with a precise measurement of the circumference of the earth. Now, how did he do that? All right. He had these observations. He observed that and so he observed that a well in Syene, he observed that at exactly or at a certain time of the day, the well doesn't cast a shadow. All right, meaning he thought that the sun's rays are directly hitting the well. That's why it doesn't cast a shadow. And so again, during this time, it is already proven that the earth is round. Okay? And so this was his initial observation. But then again, he observed a column in Alexandria at exact time. And so say, for example, 12 o'clock, also 12 o'clock noon, he observed that it casts a shadow. As unlike for the well in Syene that it doesn't cast a shadow, for this column, it is already now casting a shadow. Now, how did he do that? And so by getting now the height, he simply got the height of this column, that would be for h, and then he asked someone to measure now the distance from this column in Alexandria and to the well at Syene. And so he was able to measure that at 4,400 stades. Okay? And so we have now the measurement of h and then the measurement of s. Okay? With that, so wait, I'll just get that. If we are going to extend this now, say that is the shadow, right? And so if we are going to extend this line right here, sorry about that, that's supposed to be a straight line, it's now at an angle. Okay? Ito yung angle na yan, which is now in geometry, this angle right here is equal to this angle here. Those are alternate interior angles. Okay? By measuring now this angle, and so of course it's the earth is round, 360 divided by that angle, and then simply multiplying that to the measurement of this arc, formed from Alexandria to Syene, he was able to get the measurement of the circumference of the Earth, or rough estimate of the measurement of the Earth, which is now 40,074 kilometers, which is quite precise to the exact measurement of the circumference of the Earth. Alright? Moving on, another classical scientist who made a great impact on classical astronomy is Aristarchus. Aristarchus now determined the relative sizes of the sun and moon and distances to each. Unlike Eratosthenes, Aristarchus was not able to come up with the correct values. But what's notable here is that Aristarchus's geometry is correct. Okay, and so Aristarchus attempted to measure now the distance between the moon to Earth, moon to sun, or sun to Earth, or even the sizes of moon compared to the Earth, or the Earth compared to the sun. Okay, and so he was not able to arrive with the correct measurements simply because he did not have the initial measurements correct. And so since his initial measurements were wrong, he came up with the wrong answers also. But what's notable here again is that his methods are correct in identifying the relative sizes of the sun and moon and then distances to each. Okay, lastly, on classical astronomy, on the ideas on classical astronomy, we have the ideas on planets. And so initially, ancient or classical astronomers observed the stars, but then they noticed 5 bright stars in the night sky that did not stay fixed like stars. Okay, and so, meaning throughout the years, and so of course we have the stars observed on their place and on the entire year, but then these stars apparently they are moving from one place to another throughout the year. Okay, and so they named these planets, or from the Greek word for wanderers, because these stars are moving from one place to another. And so planets seem to move independently, so they were named after the gods. Okay? Of course, what we can see with our naked eye, or even with the aid of telescopes, are the nearest planets to the Earth. We have Mercury, Venus, Earth, Mars, and then Jupiter. Alright?